All right, on to Module 19. We are going to be talking about surface area. In the first module, in Module 19, though, we are actually just going to be talking about cross sections and solids of rotation. So the first thing we talk about surface area, you probably learned this from middle school, was you need to unfold any three-dimensional figure into something called their nets. So this is a rectangular prism. Well, I don't know why I made a U like that. Prism. The faces that it has a total of 6 faces, just like a die. And then if you unfold it, it ends up looking just like that. The next one we have is a triangular prism. Start off with a triangle. We'll extend the sides there, making some sort of like tent guy. This has... Oh, I guess we're supposed to say what type of faces there are. I don't really care. And then we're going to go ahead and draw out what a triangular prism looks like unfolded. We've got our sides, 2 sides of our triangle, and we've got a total of 3 other rectangles. Then we've got our triangular pyramid. They expect us to write this small or something. Our example of this would be, oh, another drawing, right? No. So let's go ahead and draw a base, a little point, and then just connect all of your corners to that point. And then we have a cylinder that has a two round faces, I guess we'll say 2 circles, and a rectangle. So you put a circle, do a rectangle, and then a circle. Notice that we can't have the circles be like here and here. It won't make a net. So it's got to be the top and the bottom. All right. Is there more than one way to draw a net for a solid? Yeah, it just needs to fold together, right? So I could make a triangular pyramid. I could have the rectangle. I could have our, I could have a triangle here, and then I could just like make all the triangles connect here, I think, at the point, and it should work out. Yeah, but I couldn't have it look like this, though. Then it wouldn't connect together. So you kind of just got to imagine. There's not like a rule per se on like how to arrange the net to see if it will make a 3-dimensional figure. You just need to see if it'll piece together. The other section we have here are cross sections, and in order to determine a cross section, just imagine you're taking a 3-dimensional figure and you're slicing it. So you could slice it a lot of different ways. In general, they're just going to be slicing it horizontally or vertically, but you could slice it diagonally as well, and it'll create all different types of shapes. And what we're talking about is, what would it look like if we were to slice the shape, and then we look at like what would be on the slice. So what would that slice piece of paper look like? So if I cut this cylinder right down the middle like this, then we'll end up with a circle. So that would be our cross section, would be the circle. If we take this cone and we cut it right down the middle, our cross section would be a triangle, where the base of the triangle is the diameter. If we cut it right down the middle, it'll be the diameter of the circle, and then yeah. Oh, the length is the height of the cone. A plane intersects a sphere. So if we take a sphere and then we intersect it with a plane, I don't know, imagine that's a plane or something, you will get a circle, no matter how you slice it. Even if you slice it over here, you'll still get a circle on the plane. So a circle is one of those where you can just change the size of the cross section, like that's the size of the circle, but you won't be changing the shape. Oh look, if we cut this cylinder not down the middle, what would it look like? It would be a rectangle. The next thing we have is we're going to generate 3-dimensional figures. You'll find that this will actually be useful when you get to calculus later on. we're going to rotate our figure. So if you take a triangle and rotate it around an axis, you rotate it around one of its legs, you end up getting a cylinder if you rotate this guy around. So the way that we could do that is we'll just draw another triangle on the other side, and then we'll draw a circle to show that we are rotating it around. What happens if we rotate a rectangle around this L? Well, we'll get a cylinder. Do something like that. What would it look like if we rotated this guy? Well, something like that. How would I describe this shape? I would describe it as a cone on the top and the bottom, not necessarily the same, on the top of a cylinder. So 2 cones, 1 cone on top of a cylinder that's bigger, and then 1 cone on the bottom of the cylinder that's bigger, so making like a little top kind of thing. What if we took a semicircle and rotated it? Well, then we would end up getting a sphere. If a solid had been generated by rotating a plane figure around an axis, will the solid always have circles? So like if I took this guy and I did a cross section, there would be circle. It's a circular figure. And then this one would have a circular cross sections as well. Like I could just cut along here. So it seems like we would always have a circle, circular cross sections at least. Imagine, what do you think this figure would look like if we rotated a hexagon that is on the corner around our figure? All right, then you have your assignment, 76, and I will see you later today.